In the last two lessons, we relied on finding factors or square roots to find our solutions. Unfortunately, quadratics aren't always so easy to deal with. There will be times when neither factoring nor taking square roots will provide us with solutions. For example, let's look at the quadratic equation x squared minus 14x plus 15 equals 0. This isn't an equation that can be solved by taking square roots or by factoring. In order to solve this, we're going to employ completing the square. This is a technique that will transform our equation into a perfect square trinomial. In order to see this in action, let's look at a simple binomial, such as x squared plus 6x. We know that a perfect square trinomial is a trinomial whose c term is the square of half the b term. So what we need to do is take the b term, 6, divide it by 2, and then square it. And finally add it to our binomial. Our new trinomial will look like this: x squared plus 6x plus 6 divided by 2 squared, which becomes x squared plus 6x plus 9. We have thus completed our square and turned our imperfect binomial into a perfect trinomial. Looking back at our quadratic equation, what we're going to do is first leave our broken square on the left side of our equation and move our constant to the other side. X squared minus 14x equals negative 15. Note that our b term is negative 14. Let's halve it and then square it. That will be negative 14 divided by 2 squared, which equals 49. What we want to do now is add this to both sides of our equation. X squared minus 14x plus 49 equals 49 minus 15. Now we can factor the left-hand side, which is x minus 7 squared, and the right side becomes 34. Now we have something that we can solve using square roots. We get the absolute value of x minus 7 equals the square root of 34. Our solutions are then x equals 7 plus the square root of 34 and x equals 7 minus the square root of 34. Some points should be made. It is often the case where our solutions won't seem elegant. There's a reason for this. When we start graphing equations, we'll see that the quadratic equation involves a curve. Curves often don't cross the x-axis at whole numbers. Thus, we end up at radicals or irrational numbers. Completing the square is a skill that you're going to need to keep in your arsenal. It's invaluable in solving quadratic equations, but in truth, it can be used to solve any quadratic equation. Before we move on to examples, I want to show that we can plug these solutions into the original equation, x squared minus 14x plus 15 equals 0, to check if they're correct. Let's use 7 plus the square root of 34. We have 7 plus the square root of 34 squared minus 14 times 7 plus the square root of 34 plus 15. This equals 49 plus 14 times the square root of 34 plus 34 minus 98 minus 14 times the square root of 34 plus 15. This positive 14 root 34 and this negative 14 root 34 cancel out. And 49 plus 34 plus 15 equals 98. So we're left with 98 minus 98, which equals 0. Let's practice with a few examples. Number 1, x squared plus 4x plus 5 equals 0. Our first step before we can complete the square is to isolate the incomplete square. X squared plus 4x equals negative 5. Now we can complete the square by squaring half the b term and adding it to both sides. x squared plus 4x plus 4 equals 4 minus 5. Now that the left-hand side is a perfect square trinomial, we can factor it. X plus 2 squared equals negative 1. Taking the square root of both sides gives us the absolute value of x plus 2 equals I. Thus, our solutions are x equals negative 2 plus or minus I. Notice we got complex numbers for our solutions through the aid of completing the square. Number 2. 2x squared plus 8x minus 1 equals 0. Our quadratic equation here has a not equal to 1. So we need to divide everything by 2 so we can have a simple time solving this. X squared plus 4x equals 1/2. Completing the square gives x plus 2 squared equals 9/2. Taking the square root of both sides will leave us with a rational radicand. The absolute value of x plus 2 equals the square root of 9 over 2, which simplifies to 3 root 2 over 2. Solving for x now leaves us with x equals 3 root 2 minus 4 over 2, and x equals negative 3 root 2 plus 4 over 2. This time around, we were left with a pretty nasty looking rational answer. You'll find that these kinds of solutions will be quite common when working with quadratic equations. Number 3. X squared plus 3x equals 1. Here we have our imperfect square already isolated, so we can immediately work on completing the square. X squared plus 3x plus 9 over 4 equals 1 plus 9 over 4, which factors to x plus 3 over 2 squared equals 13 over 4. Our squared binomial has a rational number in it this time around. This will happen often. Taking the square root of both sides, we get the absolute value of x plus 3 over 2 equals root 13 over 2. Therefore, our solutions are x equals root 13 minus 3 over 2, and x equals negative root 13 plus 3 over 2. Number 4. 4x squared minus 4x equals negative 15. Our final example has a 4 multiplied to a square term. Multiplying the entire equation by its reciprocal will allow us to proceed. X squared minus x equals negative 15 over 4. It's easy to make a mistake here. Don't forget to take half of the second term before you square it. Students often use 1 or 1/2 here when the correct answer is 1/4. X squared minus x plus 1/4 equals 1/4 minus 15 over 4. Simplifying gives us x minus 1/2 squared equals 14 over 4. Notice that when we take the square roots, we're going to get complex numbers here. The absolute value of x minus 1/2 equals I times root 7 over 2, which simplifies to I root 14 over 2. Finally, our solutions are x equals I root 14 plus 1 over 2, and x equals 1 minus I root 14 over 2. With this tool under our belt, we are prepared to fully factor any and every quadratic equation that we come across. However, as you may have surmised, completing the squares sometimes requires us to juggle around some numbers, and that leaves room for errors. In the next lesson, I'm going to introduce something that's drilled into the mind of every high schooler: the quadratic formula.